I've mentioned in previous videos that I create reproductions of vintage PCBs, specifically old computer equipment, test equipment boards, and this is an example of the type of board that I reproduce. I've got two of them here, as you can see, and in theory they should be identical. When I have the original boards, it makes the whole process a great deal easier, because obviously I can measure the boards, I can see how they're laid out, and frequently the documentation that is available for these old boards can be hard to find, and quite often it has errors in it, which obviously the boards themselves don't have those errors usually because they work, whereas the documents, if you follow them blindly, you can end up with a non-working board. Now the process I use is to create the schematic of the board. At that point you can usually pick up errors because you can see how the electronics are supposed to work, and if there are errors, hopefully you can pick it up at that point. The real issue comes when you're trying to decide what version of a board to make, and especially boards that have had a lot of versions or modifications over the years. So typically I will look at as many examples of the boards as I can before I start work on them. The real difficulty in doing that is that some of the changes can be quite small. They may not always be present in the documents that are available, but as you can see on most boards, somewhere you will have a revision number. Again, unfortunately, the revision numbers aren't always indicative of the actual state of the design for that particular board. Revision numbers can be made for reasons other than a completely different version. My own company uses revision numbers for identifying different manufacturers, different sales, markets, that sort of thing. So really the only safe way to proceed is to try and get as much information about actual boards as I can. I then compare each board with the other boards or the other images that I can get. Quite often I can't get an actual physical board, I can only get the images, and I then need to compare either the physical boards against the images I can find, and then compare that with any documents I can find, and I also compare the images against other images of the similar boards, and of course if I have my own boards I can create my own images. I can then do a comparison between the two. Now anyone that's ever tried to compare two different PCBs that are supposed to be the same will know that it's not always that straightforward. It can be quite easy to miss small changes. If you have small subtle differences, it can be quite easy to overlook those. Sometimes the changes are just track layout only, they're not schematic changes, but we really need a way to examine the boards and compare them in a foolproof manner. Now I used to work as an optical specialist for a company about 35 years ago, and we had some very nice optical comparators. So basically what you would do is you would take two items that you want to compare. The optical comparator would display them either side by side or would effectively overlay them, and then you could rapidly switch between one and the other, and any differences would appear to flicker as you switch between the two images. I do still sometimes use one of those machines, but there is an alternative. Now, aside from the machines being horrendously expensive and probably beyond the scope of most people that would want to copy a board, there are alternate techniques that are, to all intents and purposes, free, and techniques that you can do yourself with what you already have, and that's what I'm going to show in this video. Just easy ways to do foolproof comparison of boards, documents, diagrams, or even mechanical assemblies. It will work for pretty much anything. So the first thing you need to do is gather together images of the items that you want to compare. So you can either scan them if you've got a decent scanner, flatbed scanner, or you can photograph them. Either way, you need to try and get images that are as square on as possible, so you want to have them square onto the camera so that they don't appear in kind of a trapezoid form. You want them to be a rectangle where all the corners are at 90 degrees. The reason for that is it just makes overlaying them much easier. Also, if you've photographed them or scanned them and they are tilted, then you will need some software to allow you to rotate it back square. And then the best thing to do is to crop the image so that you're only showing the board itself. And then if you do that with all the boards and all the images you can find, make them all the same size in terms of the image size, then when you come to do your comparison, it will be much easier to spot the differences. Very good software out there, some of it free, some of it expensive. You can use software such as GIMP, which is free. PaintShop Pro is another good one for doing sort of simple manipulation of the images. But what you're aiming for is a pair of images for each board, one for the front, one for the back. Do that for as many boards as you want to compare. Sometimes you can't take the images yourself because you don't have an example of the board, but generally speaking you can find images online, or if a friend's got a board and they can photograph it, then that will speed things along. But what you're aiming for is to have a set of images for the specific board that you want to produce, and then compare that against any alternatives that you can find to look for any differences, modifications, and then you can do the same thing with these schematics. So I'll start with this pair of boards and we'll look at the comparison of the backs of these two boards, and then we'll have a look at some other boards and use the same methods to show how to compare boards and diagrams and even text. Arrow keys. So if you copy just two images to a single folder, which is what I've done here, then the arrow keys will allow you to switch between the two images. So if I press the arrow key, you'll see we switch to the alternate image, and if I press the arrow key again, we switch back to the first. So as you can see, I've cropped the images and scaled them so that they are the same size, or fairly close to being the same size. I've also just adjusted the contrast and the brightness a little bit to make them fairly similar. That just makes it easier to spot any changes. If I now hold down the arrow key, then the images will be continuously toggled, and you can now scan across the board looking for any changes. Now of course there will be a degree of flickering because the images aren't exactly the same in terms of brightness. The boards marks, they're scratched, the solder blobs are different, but what we're looking for is differences in the tracks, and it will become clear later on in this video how easy it is to see actual track changes. But as you can see here, these two boards are the same, and that's what we expected. Okay, so on that board we couldn't find any differences. They appear to be identical to each other, and that's not surprising. They were manufactured in the same batch. But sometimes there are differences and you want to be able to determine what they are. So I've got two boards here. These are two boards from the processor kit that you may have seen, and what we have is a revision 1 and a revision 2 board, and we want to be able to see if there are any differences between these. Now I know what the differences are of course, but sometimes if you're getting these boards from somewhere else and you're trying to decide which one is the one to manufacture and what the differences are between them, then again this technique will work extremely well. So if we have a look at that on the PC and do a comparison between them, then we should be able to pick up all the differences very easily, certainly much more easily than trying to look at them manually and spot any differences, which as I said can be extremely error prone. Using exactly the same technique here, I've scanned the boards, scaled them, adjusted the contrast and brightness so they're fairly similar, made sure that the rotations are again very close to each other, and we're now looking at the first of two boards. And as I said, there are differences in these two boards, and as I switch between them, then you should be able to see those differences standing out quite clearly. So I'll hold the arrow key down so we're toggling between the two boards, and hopefully you can see fairly clearly that there are differences in this board. So we've got some differences here, the spacing of these holes, the track changes here, and an extra component here. It stands out quite clearly. Down here we have some track changes, and again an additional component. Up here we have some more changes, just repositioning of some components. If you want to examine the tracks more closely, then of course just stop the toggling, and then you can just slowly switch between the two boards and have a better look at what the differences are. So down here we have another change, and you can see it does stand out quite clearly. Hopefully this is coming out clearly on the video. It certainly is very clear on the PC screen. Down here we have another change. Track here is obviously very clearly on one board and not the other. And just as importantly, in other areas you can see that there aren't any differences. So if you want to just confirm that two areas of the board are the same, this technique works just as well. But hopefully you can see that it's a very easy way to spot differences on two boards that would possibly be quite difficult to spot just manually examining two boards that you had. It might take sort of 5 or 10 minutes to prepare the images, but if you're looking at spending thousands of pounds having boards made, then it's well worth the effort. And especially if you're producing vintage boards where you want to make sure that the board you've created is as close to the original as you can get, and then this is a very good technique to use. As I say, differences do stand out very clearly. Okay, so clearly we could find the differences quite quickly using this method. The images for that board were taken by scanning the boards. Obviously that's very easy with bare boards, and especially when you have an example of each type. Unfortunately, sometimes you just don't have access to a board at all. So it might be you want to reproduce a board, but you just don't have an example of one. So what you may have to do is resort to just locating images off the internet, or again, if friends can take a picture of a board for you. Try to get an image of all the different versions that you want to compare, and then you can do exactly the same thing as we've done with the last two boards. So here we'll look at comparing two versions of a board using exactly the same technique, but where the images were sourced directly from the internet rather than from boards that we have ourselves. Sometimes you just do not have access to an actual board, and you have to make do with images when you're creating the reproduction. And this is an example of that. I have two images, both taken off the internet. I don't have an actual board of this type, but I still need to compare different versions of them to make sure that the version I'm creating matches the document that I do have. And of course what you could also do is take the information in the manual. So if you do have a layout for the tracks, for example, which a lot of the older vintage manuals do, then you can take a scan or an image of that page of the manual, and then you can use exactly the same technique to compare the image that you found of the board with those track layouts. In this case I just have two images that I've captured from the internet. I haven't actually adjusted the contrast on this just to show you what you may start off with, but as you saw in the previous images, it's quite easy to adjust the contrast and brightness to get the images the same, and then all you do is you toggle between them to make sure that they are as similar as you're expecting, or to be able to see any differences between the two. Okay, so as you can see, a bit harder that time because the images weren't quite as consistent, but even so, hopefully you can see that it's still relatively easy to identify any differences between those different boards. And of course you can get as many images as you can find and do the comparison, and then hopefully satisfy yourself that what you intend to build is correct and it matches any documentation that you have. And what you can do, of course, is take the document for the original board. Usually you can still find the manuals for them, and often they will have the copper overlay diagrams within the manual, and of course you can do exactly the same thing with that and treat it as if though it's an actual board. So in other words, you take an image of the manual diagram of the copper overlay, you scan it or photograph it, scale it to the same as the board image that you want to compare it with, and then use exactly the same technique to see if the board you have matches the documentation. And if it doesn't, again you'll see the differences flickering quite clearly. Now you can of course use exactly the same process for the schematics. So if you have two schematics and you want to quickly identify the differences, this is quite a simple schematic, but sometimes they're quite involved, and trying to count lines and traces and tracks and making sure that the designations are all the same. So in other words, is everything numbered the same, is all the text the same? That can be quite difficult, and again error prone. You can easily miss something that can cause the board to fail, and what you're aiming for is to have your first board, your first version of your board work. You don't want to start going through many iterations of the boards because that gets expensive. Also, you might end up with a subtle fault where the boards are just unreliable or don't work quite as they should. So that's where this technique comes in extremely handy. If there is even just a small change, then you will pick it up quite quickly. So for this next example, I won't use a diagram, I'll use some text, and you'll see that even though it's a fairly minor change in the documentation, it very easily, very clearly stands out as to what the change is, and that technique, as I say, will work just as well with schematic diagrams or any other sort of diagram. So we'll have a quick look at that now. Images. So if you have the manual or some text that you want to compare, then all you do is exactly the same process. You get a visual copy of each of the two, you scale them so that they are the same size, and then you put them into a folder on the PC, and then use a slideshow to toggle between the two. So here we have some text. It's very error prone to read text and try to find errors or differences, but using this technique, if I now start to toggle between the two copies that I have, hopefully it's very clear where the difference is in this text. So in this case it's a single letter that's missing on one, and if I toggle slowly it's very clear, and if I toggle more quickly then you can very clearly see the flickering where the difference is. And it's also very clear that the second paragraph is identical in both copies. Okay, so hopefully you found that interesting, maybe of some use if you intend to produce reproduction boards. If you've got any comments or any questions, then please let me know.